Hello everyone and welcome back to the channel. If you're new, my name is Mike and this channel is called Build or to Buy It, where I build things from scratch and determine whether it was better off to build it or should I have bought it. The current project I'm working on is building a trailer from scratch. We're going to pick back up where we left off on the first video, which will be cutting the two main frames to length and doing a little bit of miter work on the corners in preparation for welding on the front main cross member and the rear main cross member. I do want to touch on one thing. When I initially talked about building this trailer on top of the other flatbed trailer I had, I realized that not everybody may have the ability to have a workbench that size, so that if you don't want to do it on the floor, the same principles of using the adjustable jack stands like you would have on an RV would apply. Even if you didn't have a trailer to build it on, you would just set the main frame members up on those jack stands and use those to level it up. So at any rate, just wanted to touch on that. And so I guess we'll get going with cutting these to length. As I mentioned, I think earlier, most of the C-channel comes in a little over 20 feet. Usually there's anywhere from 1 inch to 2 inches, sometimes a little more extra length there. And so the trailer's 20 feet exactly, so I need to cut these down to length. The channel's also a little bit deformed on each end because of the shearing process. Bring you in here, you probably can see the channel's a little bit twisted and bent from the shearing process. So again, that's why well, I'll go ahead and cut it to length. I'll use the plasma cutter like I did the other pieces we cut in the first episode. I want to touch a little bit on the way I mark the metal. Sometimes I'll use just a traditional silver metal marking pencil. Sometimes this is a tool from, spelled Hultafors, Hultafors. It's mostly used for construction, but it's a pencil that you can buy multiple colored of inserts. So they have orange, regular, black, yellow, whatever. They're held inside of the tool. It's kind of like a mechanical pencil, but then it has a holder with a belt loop on it that it snaps into. So this you can be on your belt and you can take it in and out. And then it has a small sharpener built into the holster affair, so you can sharpen it. So sometimes I use that. It's kind of the yellow shows up pretty well on the steel. And then the last method I use, if I'm going to be adding a lot of heat to where a marking pencil wouldn't show up, I just use a carbide scribe. You can buy these in like packs of 3 for I think $7 or $8 on Amazon. It just has a carbide tip in it, and it scratches through the meal scale really well. So it leaves a nice sharp line that you can see whether you're grinding or plasma cutting, so on and so forth. So as in the last cuts I made, I'm going to grab my straight edge here, and the rest of the stuff I need. Again, my plasma cutter, it's make the offset for that, so I know where to put my straight edge at. And I'll probably only make 1 or 2 of these cuts on camera. You don't want to be bored to death by watching the same cut multiple times. Get some gloves on. Hopefully the heater's running in the background. Hopefully that doesn't create too much background noise. If any of you are wondering about the plasma cutter I use, it's not a high-end machine by any means. It's just there's a zillion of them on Amazon. Most of them go by the term cut 50, meaning they're 50 amp. So this one, at least on the dial, will go a little bit more than 50. But for this kind of material, really thick stuff, you have to slow down, but it does 1/4 inch pretty easily, which covers most of what I do. If it's any thicker than that, I'll just use the cutting torch. So on these, again, I'm gonna pause it here and see if I can get a better angle than I did on the first episode. I'll put the lens on the camera and come around and change the camera angle and see if I can get you a little bit better view. So stand by. All right, that should give you a little bit better view on cuts like this where I have a scrap piece instead of trying to make a plunge cut where it'll sometimes make the line or the cut not quite as smooth, where this just has this 3/4 of an inch or so of waste on it. I'll just start out from the edge and then work my way into the straight edge, and that way you get a little bit better cut. I'm going to go ahead and cut these off fully square. There'll actually be a miter here on this edge. So I'm going to cut them off square for now to make room, and then when I tip them up and cut the actual miter, I'll probably do that with a cut-off wheel. We'll clean this up a little bit and then I'll cut the other one. Again, this edge here isn't square, but it doesn't need to be because there'll be a miter on that a little bit later. Take a closer look here at using the straight edge. We end up with a nice square cut. Okay, I'll bring you back around. We'll get set up on the other one and make a second cut. Okay, I changed my mind. I'm going to go ahead and cut since we're on this one frame rail, we're going to go ahead and cut the miter. And then that way you'll see the whole process on each one. But before I do that, I want to talk a little bit about how I cut the miters, and it kind of helps with weld prep. So a person could cut a miter one or two different ways. You could cut it this way, which is a miter that cuts across the full cross section, but when you make this joint together, that leaves no area for the weld other than if you would create a bulbous weld on top of this, which is not a good thing. You want to have it V'd out, the equivalent of V'd out. So if you cut your miter, or when I cut my miter, I come back the thickness of the web, and then leave that section square, and then cut the miter from there. So when you put it together, you actually have this they're touching in this very corner, but you have this little notch, in essence the same as having to go through and grind out the V notch for the weld. And so this leaves you a place to put your weld in here, gives you a nice radius corner and gives you full penetration. So anyway, that's the cut I'm going to make, or that's the scribe I'm going to make. I'll scoot you up here so you can see, hopefully see the top of the flange. So instead of taking the miter all the way, get a different pointer here. Get my hands out of the way. Try to get you a better view. So instead of bringing the miter all the way to the very point of the corner, like I said, I'll scoot back. I'll draw a line here. So this is in essence the thickness of the web. So my miter is going to come to this point here instead of all the way to this point. So I bring it up here and make my scribe. And after I make the cut, I'll zoom you back in so you can see how that squared corner is still there. So I'm going to scoot the camera back on this. It's such a short little cut, and this is fairly thick here for the plasma cutter. So I'm going to use a cutoff wheel instead. I'll scoot you at a different angle so you won't, so you can still see, and I don't blow sparks all over the camera. Get out my PPE. I'm just using a 5-inch. I think it's 1/32. Let's see here. It's actually marked as 1/10 of an inch thick. 4.5-inch cutoff wheel. Some people you hear them call a skinny wheel, things like that. It works pretty well for slicing through. All right, so we got that cut made. I'll change the angle here. So you can see that I left the thickness of the flange here. So once I get another piece cut, I'll hold it up there, and that'll leave the area, the little fillet, or the weld prep area for when I weld it. I'm gonna flip the beam over here. We'll cut the other miter, and then this end will be done. So that's not quite as quick as the plasma cutter, but it makes a nice clean cut. Have a little bit better control over the angle. So that's one side done. You probably don't need to see me do the other side. It's the exact same process. So I'll get those cut, and then I'll bring you back, and we'll go on to the next step, which will be setting up those main front and rear cross members and start tacking those in place. We've got all of these corners mitered on the long pieces, and we've got the 2 front and rear main cross members here. We've got those also mitered and cleaned up, and we're going to move on with that today. So what I've got going on here, I'll set you up on the tripod. So the next thing we need to do is I need to make sure the main frames are where they belong in regard to width, squareness, not only from corner to corner, but also squareness. And if we use this framing squareness in this regard, as well as squareness in this regard. So I did a little bit of setup off camera just so you weren't bored with me walking around measuring and measuring and measuring. And I'm pretty close right now. I did temporarily set one cross member. This cross member here is just temporarily set in there because the cross members need to fit. They're cut to length already, and because they need to fit inside the frame, if I would have squared this up, welded an end cap on, and didn't have the measurement exactly 100% spot on, then trying to fit the cross members in would be tricky. They'll have to slide in from one end. So that cross member is temporarily in there just to make sure that the dimensions left to right, or the width, is set perfectly. That is real close to where one of the cross members will sit. The cross member is sitting on a block to space it up roughly in the middle. You can't set the cross member on the bottom because C-channel, if you're familiar with, the flange is tapered. It's not flat, so it's much thicker here near the corner than it is on the outside. So if I was to, and there's a radius, so if I was to try to set the cross member on the bottom, it's going to continuously try to scoot the frame out. So those are sitting up on a couple blocks, which gets it really close to the finished height anyway. So we'll kind of go over some of the rest of the measurements here. I've got just a cross member. I'm using a cross member to clamp the two sides together so they can't move. I'll put another cross member up here, clamp that, and that'll let me hold everything in position once I have it squared corner to corner. It'll also let me check to make sure the main frames are not leaning in or out, which this one's actually leaning out a little bit now. So I'm going to quit jabbering at you here, and I'll probably time-lapse this so you're not bored to death, but I'm going to take some more measurements here, do a little bit more squaring up, and then I'll pick back up once we're ready to set one of the front, or set the front main cross member up in place. Okay, that gets it pretty close right there. As far as in this up-down plane, from the frame being square, corner to corner, the equivalent of corner to corner, that's pretty much right on the money. So I'm going to go down to the other end and set up the same scenario so that it keeps the channel from twisting a little bit on that end. Before I do that, I think I'll set one of these up here just to see how it's looking. The other advantage of using one of the cross members is it gives you a little shelf to put this on. In the last episode, I was talking about when I cut these miters, about leaving the way I square cut the corners. I'll get you in here a little closer and you can kind of see what I'm talking about now. It leaves that kind of a V-notch right here so that it leaves a place for a fillet weld versus having to build all the weld up just on the outside corner. I will go ahead and V this out, this top part, and then the inside web. The trailer's actually upside down technically. I'm going to build it, makes it easier to set the axles and things up on there. And then I will flip it over when it comes to finishing up some of the stuff. But for the ease of putting the tongue on and the axles, it's a lot easier to let gravity work in your favor instead of fighting against you. So, but anyway, these will get welded on both sides. Everything will get welded on both sides. I'll do all the welding from this position. Then when I flip it over, I'll come back so I don't have to try to lay on my back up under there and do overhead stuff. So anyway, I think I'll pause it here and I'll go down to the other end because it takes a little while to set this up, and then I will bring you back when we're ready to talk about the next steps. All right, So I've got the other end mocked up basically the same as this. Very similar, with a couple of cross members clamped in place to set up the spacing, and also that locks that width in down there. I did a corner to corner measurement and I was within a 32nd of an inch. So that tells, the square is fine to hold up to the framing square like this, but ultimately the corner to corner is a much more accurate measurement. So I'm going to go ahead and do a couple tacks here so it won't move, so then I can take the clamps and get out of the way, and then I'll give you, we'll go around with the square and I'll give you kind of a close-up of the different ways I check for square. So we'll get that done, and then we'll do the close-ups. For these tacks, I'm using just a conventional solid core wire. When I switch over to the full weld out, I'll switch to a dual shield wire. You get better penetration. It deals with the mill scale a little bit better. So, but for the tacks, this will be fine. Plus, with the dual shield, you can run, when you run your verticals, you can run uphill or downhill. So that tack's in place. Let me get this stuff out of the way for you. All right, let's see if I can get you in a little bit closer here to what I'm looking at. So I check for square in actually 3 different planes. I check for square this way. So you can see we have a nice tight gap there and a nice tight gap there. But again, the corner to corner gives you a much better or more accurate method of checking square this way. The other 2 ways I check for square is I put the square, let's see, I put the square along the bottom of the main rail and check that this front rail right here is basically plumb perpendicular up and down, which it is. And then I also check the same thing, but on this side. So I put the square up there and check that the side piece is also a bit, in essence, plumb and square to the ground. Basically, since the trailer I'm building it on was perfectly leveled in both axes. I'll take you down here real quick, basically just to show you I had the basic same setup down here at the back. None of this has been ground yet for weld prep, and it's just sitting in place again to make sure the width was correct. So when I did the corner to corner measurement, it was accurate. So the next step will be to go down, and I can't do weld prep and tack that other end because I need to have all the cross members have to be slipped in. They can't. There's no way you would tip them in there. They're too thick. I suppose maybe the ones in the middle you could probably bow the channel out enough to get them in there, but I'm not going to do that. So that other end's not tacked in. It's just sitting up there. So I'll pull that end piece off, slide all of the cross members in, get them in their approximate location. Again, I'll prop them up on blocks so that they don't interfere with the curve at the bottom of the channel. And then I'll go ahead and tack weld that which would be the rear of the trailer, tack that in. And then before I do any final welding, I'll tack all of the cross members in place because there's just slight, the channel isn't perfectly straight. If I don't know if you can see it or not, but if you basically can see down the channel, there's just a very slight flex in it. It flexes really easily on that plane. So I want to pull that in perfectly straight before, and so I'll pull that in up against the cross members and tack those in place. And then we'll switch the wire over to the dual shield wire, and I'll go over some of that welding. I'll weld in the front and the back first, and then just start burning in all the cross members. Again, to keep from having to try to lay on my back or crawl around on the floor, I'll weld all the verticals and the tops, and that'll hold everything in place well enough to do the tongue and set the axles up in place. And then hopefully the weather's a little better by then, and I'll move it outside and I've got a small crane or jib attachment for my tractor that I can pick it up with and flip it over and then bring it back in and do the rest of the welding there. So for now, I'll bring you back once I have the cross members in place, and we'll do a little bit of weld up.